But this is about Cummins, really, and partially Ram.
Yeah, that's correct.
But mostly Cummins. And here's the thing. Cummins published this page, this document on their website that has to do with a gasoline-powered 6.7 liter straight six engine.
2 million miles of real-world testing. That's what Cummins' shocking new gasoline engine has already endured before its official launch. This isn't just another gas engine. It's the B6.7 Octane, built on the same platform as their legendary diesel workhorse. In today's video, we're breaking down exactly how Cummins engineered a gasoline engine that delivers diesel-like torque.
That's what they did.
Or even compressed natural gas.
That's right.
All of the above. So they're calling it fuel agnostic engine. Basically, like you said, the base engine is there, and then you can add different heads and different fuels to it.
They are about to introduce all new tech. Now imagine this. Imagine having an engine block. So you got your pistons, your crank, all that other stuff. But on top, you can sandwich either a head that will run gasoline, a head that can run diesel, or a head that can run hydrogen.
But I'm really curious about this because, and let's look at this document together. If you could zoom in here with us. This is according to Cummins, and we'll get to Ram in a second, okay?
Yeah.
But this is mostly Cummins news.
Up to 660 pound-feet, while eliminating the headaches of DEF systems and complex emissions controls. I'll show you the ingenious design that allows this engine to run on regular 87 octane gas while still meeting the strictest emission standards coming in 2027. Before we move on, I'd like to ask you a small favor. If you appreciate this content, please take a second to like this video and subscribe to the channel. Over 98% of you watch the videos without subscribing. It costs you nothing, but it makes a huge difference to us. So, did you click the subscribe button? Great. Thank you so much. Now, back to the video.
They're saying that their B 6.7 liter architecture platform will be able to produce up to 325 horsepower and
660.
How does a diesel engine company suddenly create a gas engine? When Cummins announced they were making a gasoline engine, many people thought they were starting from scratch. They weren't. Instead, they took an approach that seems obvious in hindsight, but required serious engineering know-how to pull off. The B6.7 platform isn't new. It's been Cummins' diesel workhorse for years. There are millions of these engines on roads worldwide, racking up billions of miles of proven reliability. What's remarkable is that rather than designing an entirely new gasoline engine, Cummins took their legendary diesel block and transformed it while keeping the core architecture intact. The 6.7 liter inline-six layout is naturally balanced with reduced vibration compared to V8 configurations. This characteristic carries over perfectly when switching from diesel to gasoline applications. The engine still feels smooth and controlled under load, which is critical for work trucks that operate at high stress for long periods. Engineers didn't just swap fuel systems though. They modified the combustion chamber design, adjusted compression ratios, and completely redesigned the fuel delivery systems. But they kept the robust foundation that made the diesel version so dependable. The modifications are primarily focused on the engine's head, allowing everything else to remain familiar. One of the biggest advantages of the gasoline B6.7 octane is eliminating complex emission systems. Gone are the DEF fluid tanks and DPF filters that diesel operators hate dealing with. This simplification makes the engine up to 10% more fuel efficient than competitors while still producing impressive torque, up to 660 pound-feet. That's diesel level pulling power running on regular 87 octane gas. For fleet maintenance shops, this shared architecture is a game changer. Mechanics already familiar with the diesel B6.7 won't need to learn everything from scratch since the block layout and many service points remain similar. Even better, the extended oil change intervals reach up to 15,000 miles, something almost unheard of in gasoline engines, and a clear sign that Cummins transferred their diesel durability expectations to this gas offering. What makes this engine compliant with strict 2027 EPA and CARB standards? The answer lies in its fundamental design approach. By starting with a proven diesel architecture and optimizing it for gasoline, Cummins created an engine that runs cleaner while maintaining commercial-grade performance. The engine uses passive catalysts for emissions control, further simplifying the system and reducing maintenance needs. This engineering approach represents a fundamental shift in how we think about commercial engines, not as strictly diesel or gasoline, but as platforms that can be adapted to different fuels while maintaining their core strengths. What if an engine could run on almost any fuel? That's the revolutionary concept behind Cummins' new approach that has the entire industry talking. The B6.7 octane isn't just a random product Cummins decided to make. It's actually part of a much bigger strategy that's changing their entire business model. While most engine manufacturers are picking sides between traditional combustion engines or going all electric, Cummins is taking a completely different path. They've created what they call the HELM platform, which stands for higher efficiency, lower emissions, and multiple fuels. This approach allows the same basic engine block to be configured for gasoline, diesel, natural gas, or even hydrogen. Think about what this means for manufacturing. Instead of building completely different engines for each fuel type, Cummins uses a common architecture and just changes certain components. This reduces waste by cutting down the number of unique parts needed to make different engine types. For truck makers and fleet owners, this creates amazing flexibility. They can choose whatever fuel makes the most sense for their specific needs without having to change their entire vehicle platform. The B6.7 octane specifically targets urban delivery trucks and school buses where gasoline infrastructure is already in place and where emissions regulations are particularly strict. These applications don't always need the long-haul capabilities of diesel, but still require serious pulling power. Kenworth has already jumped on board as the launch customer, putting these engines into their Class 5 through 7 conventional trucks. When a major manufacturer like Kenworth makes a move like this, it's a significant vote of confidence in the technology. What's most interesting is that the HELM platform isn't just about today's fuels. It's designed as a bridge to Cummins' Destination Zero initiative. This long-term strategy aims for zero emissions while recognizing that we can't just flip a switch to get there. The transition requires practical steps along the way. This approach gives fleet operators a clear path forward as regulations get tighter every year. Instead of completely replacing their vehicles and maintenance infrastructure, they can adapt to changing requirements more gradually and cost-effectively. The HELM platform creates a bridge between the heavy diesel engines that dominate commercial transportation today and the zero-emission vehicles of tomorrow. By improving internal combustion engines now while preparing for future technologies, Cummins is positioning themselves at the center of this massive industry transition, no matter which direction fuel technology ultimately goes. The B6.7 octane represents more than just Cummins' first gasoline engine. It signals a major shift in commercial engine design for the decades ahead. Some industry insiders are already calling it a game changer for fleets looking to upgrade without jumping straight to electric vehicles. Diesel isn't dead, but the lines between fuel types are definitely blurring. Manufacturers now focus on flexible platforms that adapt to changing regulations and market demands rather than fuel-specific designs. The real test comes later this year when Kenworth puts these engines in their Class 5 to 7 trucks. Will this diesel-based gasoline engine actually deliver on its promises of diesel-like performance with simpler maintenance? We'll soon find out.